Hello guys, today we're going to be doing 167, 2 sum 2, input array is sorted. So it says given a one index array of integers numbers that is already sorted in non-decreasing order, find two numbers such that they add up to a specific target number. Let these two numbers be numbers index 1 and numbers index 2, where 1 is less than or equal to index 1, less than index 2, less than the numbers dot length. And it says return the indices of the two numbers index 1 and index 2 added by 1 as an integer array of length 2. Okay, so the tests are generated such that there's exactly one solution, so you're never going to have a case where the target does not, there is a target and like these numbers don't add up to it. So Leetcode says this is a medium problem, but honestly, once you kind of get once you just look at the problem and you understand like there's a specific pattern to solve this, which is you can kind of see it says it wants you to use constant extra space, so you can't use a hash map or a hash set because it will continue growing in memory. So the way to solve this is that you can use this. You can use two pointers, or you don't even need two pointers really. You can just use one simple pointer if you want to. But for me, I would solve it in two pointers. It says you're given an array of 2, 7, 11, and 15. So 2, 7, 11, and 15, right? And in this array, you're going to be having a pointer that starts in the beginning, and I'm going to call it left, and then you have a pointer call it right. And in this case, the target we had in the example was 9. So you can see 2 plus 15 is 17. So you can see here the sum of this is greater. So 17 is greater than 9. So you're going to want to move the right pointer over to the left. This way, just because the numbers are in ascending order, as you decrease the right pointer, the number will decrease as well. The sum will decrease as well. So now you have 2 plus 11, which is 13. 13 is still greater than 9. So you're going to want to move the right pointer again. And you see we have a sum of 2 plus 7. And you know 2 plus 7, 9 equals 9. Here you can just return the index plus 1 because as it says in the problem, it is a one index array of integers. So all you have to do is just return the pointer indexes, which in this case is 1 and 2. So 1 and 2. So we can just type out the solution. Every time I'll type out something, I'll let you guys know what I'm doing. So yeah. So let's redraw this real quick. 2, 7, 11, and I believe it was 15. And we have a target of 9. Okay, so we're going to start by initializing two pointers, beginning at the first one, which is left, and one at the end, which is right. You can honestly do this with one pointer, with left and right being where right is one ahead, so right could actually just be right here too, but I prefer it to be like this. But here, so we're going to do this part. We'll initialize our left and right pointers. Our left pointer will first point at the first index, and our right pointer will point at the first index. So left is currently pointing at 2, and right is at right is at the end. Sorry about that. The array is called numbers. So length of the number is -1 to get the last value, which is 15. Okay. So you want to make sure, in this case, right is never out of bounds. So while right is less than the length of numbers -1. So you're gonna get an error if right ever reaches right here. So while this statement is true, so while right never hits the end, like out of bounds, this while loop will always be true. You can just have it like that. Okay, so Now you want a total, like as I said earlier, you want to sum something that adds up 2 plus 15 together. You can make a variable called sum and equal this together. So equal these two values together. So 2 plus 15. So you want a variable to store that value. This variable will be numbers of left plus numbers of right. And numbers of left just accesses the actual values inside the array. So, and numbers of right accesses the value inside the array. So in this case, numbers of left is 2, and numbers of right is 15. Right? Oh, I guess we shouldn't really call it sum. That's a bad naming. Here, I'll call it capital sum. Okay. So now you want to compare the sum. So to determine if you want to move the left and the right pointer, in this case earlier, we saw that we moved the left and right pointer based on a condition. And that condition is if the sum is greater or less than the target. Right? So if the sum is greater than the target, right? Oh, sorry about that. Right. Okay, so if the sum is greater than target, in this instance, you can see in this instance, it will be 2 plus 15, the left and the right pointer. And that equals 17. So that's greater than 9, which is our target, right? So this is our sum, and this is our target. So we want to subtract, not subtract, move the right pointer over one left. So you want to decrement the right pointer. Because, like I said, it's in ascending order, so the way, if you move the right pointer left, it will decrease. If you move the left pointer right, it will increase the value of the sum. So we'll want to decrement, right? If sum is less than the target, if the sum is less than the target, we'll want to move the left pointer to the right. Right? Else, we hit a point where they equal to each other. Where, let's say, let's fast forward, 2 plus 11 is 13. 13 is greater than 9. The right pointer moves to the left one more time. 2 plus 7 is 9. 9 equals 9. So you want to return the index of the left pointer and the right. And it tells you to return the index of the two numbers added by 1. So all you have to do is do left plus 1 and right plus 1. And hopefully this works. Let's run it real quick. Hopefully I didn't get anything. Yep. As you can see, this is a very intuitive solution. And it's a constant space. And it's a medium problem. This is a very good first medium problem you guys can tackle. Because it's honestly not really a medium problem. I would say it's easy. It's just 2 pointers. As long as you understand the concept of how 2 pointers is implemented, you'll be able to solve it. Let's submit the problem. Yep. All right. Thank you very much, guys. You guys have a great rest of your day.